one of the places I saw people having a lot of trouble on the first exam was places where you had to add fractions that were made out of functions, polynomials, and things like that. So I wanted to address that. If you want to add fractions made out of functions, I guess it's first best to look at adding fractions made of numbers. And maybe we can apply the same ideas from the easy example to the harder example. So let's try it. So adding fractions. Alright, so if I wanted to add two numbers like 1/5 and 1/3, what do I need to do then? You probably remember from way back that what you need is a common denominator, right? So in this case it should be the least common multiple of 3 and 5, which is 15. So in each part you just have to add in the piece that you're missing. Like 1/3, I have a 3, but I don't have a 5. So let's multiply by 5 over 5. It didn't change this 1/3 because I just multiplied it by 1. Over here, I have the 5, but I don't have the 3, so let's multiply it by 3 over 3. Okay, so what that means is, on the top, I've got 3 times 1 is 3 over 15. On top of the other fraction, I've got 1 times 5 is 5 over 15. And now I've got two fractions with the same denominator. Now I could just add up the top parts. 3 plus 5 is 8, so this adds up to 8 over 15. Not so bad, right? So let's try it when we've got x's in here, variables and so forth. Let's say I got an expression that I need to add up, like 1 over x minus 4 plus 2 over x plus 5. I want to apply the same idea to it. We've got two different denominators. Instead of being 3 and 5, they're now x minus 4 and x plus 5. So they're still numbers, we just don't know what they are. So what's your common denominator? The least common multiple of x minus 4 and x plus 5 is just going to be x minus 4 times x plus 5. Same reason it was 3 times 5 above. So let's add in the pieces that we're missing. This one has an x plus 5, but it doesn't have an x minus 4. Whatever I do on the bottom, I have to do on the top. That way I haven't changed anything. Now over here I should be able to do the same thing. I have an x minus 4, I don't have an x plus 5. So let's multiply by x plus 5 over x plus 5. Alright, so what did we do before? You don't want to cancel out, that'll take you back where you started. What you want to do is go ahead and multiply out your numerators. So you've got, on top of the fraction on the left, you've got x plus 5, and let's leave the denominator factored, x plus 5 times x minus 4. On top of the other one, I'm multiplying 2 by x minus 4, so I've got 2x minus 8. Right, don't forget to carry your 2 here, over the same denominator. Now, we've got two fractions that have the same denominator. What did we do last time? We had 3/15 and 5/15. So we left the 15 on the bottom and we added the two top parts. Let's do the same thing here. Denominator is still going to be x plus 5 times x minus 4. And now what's my numerator? It's just going to be x plus 5 plus 2x minus 8. Which is going to simplify to what? X plus 2x is 3x. Plus 5 minus 8 is minus 3. And I've still got my two denominators, x plus 5 and x minus 4. So now we've reduced this sum of two fractions with different denominators into one fraction that's going to be easier to deal with. Now, let's say we got this in an equation, like what happened on the exam. So, suppose you got something that looks like 1 over x minus 4 plus 2 over x plus 5 equal to 3 over x minus 4 times x plus 5. Alright, so one way to attack this would be to do exactly what we did before on the left-hand side. We've got two different denominators, so let's get a common denominator and add them up. Now, as it happens, that's exactly what we just did. So our previous work is going to tell us what? We got 3x minus 3 on top, and we had x minus 4 times x plus 5 on the bottom. Alright, so that's what's equal to 3 over x minus 4 times x plus 5. So you notice we're in luck. We have exactly the same denominator on both sides of the equation now. So what can I do? Well, I can multiply both sides by that denominator. Remember, you're allowed to do whatever you want to both sides, as long as you do it to both sides. So what happens? It just cancels out, right? So you can write 3x minus 3 equals 3. Alright? So add 3 to both sides, you get 3x equals 6. Divide by 3, you get x equal to 2. And that's what we're looking for that kind of an answer. Now there's an easier way to do this problem, and I'm going to get to it in my next video.